Hello and welcome to another video from the 10 a day series. Today we are going to be discussing 10 questions from one of the topics which aspirants are scared of the most. This topic is functions and we will try to look at the questions that are moderate to even some questions that are difficult so that it helps you build confidence in this particular topic. So the way to go about this particular video is look at a question, pause the video, try the question out on your own and then have a look at the solution that will follow. Also, if you enjoy our style of teaching, it is recommended that you have a look at the programs that we have floated. We have programs that cover the very basic topics. So for someone who is preparing from scratch, there is a program for you which is called the Power Prep program. Also for people who are looking at slightly advanced level of preparation, you are looking at more problem solving kind of programs, then we have a mastery program to help you with the same. So do check out the programs using the link in the description box below and we will start with the first question of this particular video. So go through the question first and then have a look at the solution that's going to follow. Now, right off the bat, we have two functions that have been defined in this particular question. The first function says square bracket x. The second function says curly bracket x. Now the square bracket x function tells you that it is going to be the greatest integer less than or equal to x. Now what is a function? A function is basically something wherein you will basically put a number or an input into a machine and the machine will give you an output. So in this particular case, square bracket x is the function. It is the machine that is going to give you some output. What is that output? There is going to be an integer that is going to be an output. It is going to be the greatest such integer. What kind of integer are we looking at? One of these two. Either it will be the greatest integer that is less than x, or it is the integer that is equal to x. So if x is an integer, that is going to be our answer. And if x is not an integer, we have to look at the greatest integer that is less than x. So in this particular case, this is the greatest integer function as it's called. The second thing is the least integer function or the smallest integer function. Curly bracket x asks us to find out the smallest integer that is greater than or more than or equal to x. Now given that x is not an integer, so let's say for example we are talking about x equals 3.2 for that matter. Now if x is equal to 3.2, what are we going to get here? If x equals 3.2, then square bracket x is going to be the greatest integer either less than or equal to x. Now for all practical purposes, we are not really looking at equal to bits because 3.2 is not an integer because x is not an integer. So we have to find the greatest integer that is less than x. So if I'm looking at 3 here and 4 here and this is the number 3.2, let's say, I have to look at the greatest integer that is less than x, less than 3.2. What all integers are there? 3, 2, 1, 0, minus 1, minus 2, minus 3. All these are integers that are less than 3.2, which is the greatest such integer. This. So in this particular case, we are going to see that square bracket of 3.2 is going to be equal to 3. Similarly, if you are looking at the curly bracket 3.2 function, then what are we going to get? We have to find the smallest integer that is greater than 3.2. What all integers are greater than 3.2? 4, 5, 6, 7, 8, 9, 10 and so on and so forth. Which is the smallest of these integers? It is 4. So we will be able to see that square bracket of x is going to be the integer that is to the left of this number and curly bracket of x is going to be the integer that is to the right of this number. Now considering that the integer to the left and the integer to the right are going to be separated by 1, square bracket x minus curly bracket x is going to be in this particular case 3 minus 4, that is minus 1. In fact, if you look for any number that you have, let's say for example, I'm looking at a number between minus 2 and minus 3. Let's say we are looking at minus 2.8. Now in this particular case, if I want to figure out the greatest integer that is less than minus 2.8. So we are looking towards the left, less than minus 2.8. What is the largest such integer? It is minus 3. What about curly bracket minus 2.8? That function asks us to find the smallest integer that is greater than minus 2.8, which is minus 2. What is the difference between minus 3 and minus 2? Minus 3 minus of minus 2 is again going to be equal to minus 1. So the correct answer here is option A, that is minus 1. Let's look at the next question. Again, try this question and then have a look at the solution. Now, this is a complicated function because it involves you inputting the value of x and the machine is going to tell you what is the value of root of x plus 2 into 5 minus x minus 1 upon root of x square minus 4. Now, you have to understand one thing. Square root of negative numbers is not defined. right? So यहाँ पे you have to understand that square root of negative numbers is not defined. So what do we get in this particular context? If square root of negative numbers is not defined, I will have to ensure that x square minus 4 is greater than or equal to 0, or x square has to be greater than or equal to 2, which basically tells me that x has to be, or x square has to be greater than or equal to 4, x has to be greater than or equal to 2, or less than or equal to minus 2. I also know that because this is in the denominator, this cannot be equal to 0. So I know that the value of x will either be greater than 2, or the value of x will be less than minus 2. So one of these two has to happen for this particular identity to be true. So x will either be greater than 2 or it will be less than minus 2. Now you also have to account for this particular bit. So if you look at this particular bit, you will be able to see that x plus 2 into 5 minus x. So we have to ensure that x plus 2 multiplied by 5 minus x is greater than or equal to 0. Now this could be 0 because we don't really have this in the denominator. So what do we get in this particular case? X plus 2 into 5 minus x should be greater than or equal to 0. So think about values. What if x is a really large number? If x is equal to 100, this part will be positive, but this part will be negative. So it will not be greater than or equal to 0. So x goes beyond 5, this bracket becomes negative. So we cannot let it go beyond 5. So we have to ensure that x is less than or equal to 5. On the other hand, if you look at it, what exactly can be the negative values that will create a problem here? We know that x plus 2 into 5 minus x. So if x is a negative value, we have no problems with this bracket. But here, if you look at it, because this will always be positive. But if you look at this bracket, if you go beyond minus 2, then it's going to be a problem. So we also have to ensure that x is greater than or equal to minus 2. So x has to be between minus 2 and 5. So we also have to ensure that x is less than or equal to 5 and greater than or equal to minus 2. Now I have to ensure that both these things are satisfied, and then look at the options. Now in the first option, we are saying that negative values are also okay, but they aren't, because if we have, let's say, minus 5 here, then I am going to get root of minus 3 multiplied by 10, which is going to be root minus 30. It will not be defined. What about 2 to 5? It makes sense because this one has to be greater than 2 or less than minus 2, but I cannot have this less than minus 2. So what I have to ensure is that x is greater than 2 because of this identity, and x of course has to be less than or equal to 5. So this will be a decent range that we can expect. Of course, a better way to write this should have been 2, 5 in this fashion, because 5 is also a part of the solution set, but which of the following could be a set of real values. So I think this is a good option to go with. 3, 4 is a decent option, but it is not as concise as 2, 5. So in this particular case, we will not mark this, we will mark this as the answer, and none of these of course is not going to be the answer. So the correct answer here is option B. Let's look at the next one. The graph of the polynomial f of x equals x raised to 5, ax raised to 4, bx cube, cx square, dx plus e has 5 distinct x intercepts, one of which is at 0, 0. It basically means that if you put x equals 0, then the value of this expression also becomes 0. But if you put x equal to 0, what will happen? These terms will all become 0 because the value of x is 0. So I'll be left with e. So I'll be able to say with certainty that e is going to be equal to 0. Now if e is equal to 0, what else can we see here? We can see one thing. When f of 0 equals 0, it basically means that 0 is one of the roots. And we know that they have 5 distinct roots. So the other roots have to be non-zero. So let's say, for example, we have 5 roots: 0, R1, R2, R3 and R4. Now, if you look at the kind of way in which we can write these roots, I will know that if I take 4 roots at a time, let's say, if I take 4 roots at a time, the product will be 0 into R1 into R2 into R3. This could be a combination of 4 roots, or I can have 0, R1, R2, R4, or I can have 0, R2, R3, R4, or I can have 0, R1, R3 and R4. So these 4 combinations will definitely give us 0, but the last combination R1, R2, R3, R4 should not be equal to 0. Now if you look at this particular part, what is this? This is going to be a part of this bit wherein we are saying that, okay, a is nothing but, or the sum of the roots taken one at a time is going to be equal to minus a in this particular case, sum of roots taken one at a time. What about the second case? Sum of roots taken 2 at a time is going to be equal to b by 1 in this case. sum of roots taken 3 at a time is going to be equal to minus c by 1 in this particular case. Sum of roots taken 4 at a time is going to be d by 1 here. And of course, product of the roots or sum of roots taken 5 at a time, this is going to be equal to 0 because one of the roots is 0. So E was equal to 0. But we will know that if we take 4 roots at a time and we try to make this particular bit equal to 0, it's not going to be possible because I will have one term that cannot be equal to 0. Because it will mean that R1, R2, R3, R4, at least one of them is equal to 0, but there are 5 distinct roots. So I will definitely have a term that will make sure that this part is definitely not equal to 0. So D is the coefficient that cannot be equal to 0. Also, if you think about it, you will be able to say that if D is equal to 0, then this expression can be written in the form of x square multiplied by ax cubed plus bx square plus cx plus cx rather. That is what we'll be able to write this as. So that will basically tell us, or I'll just write x raised to 3 as well. So x raised to 3, a times x square, b times x plus c. I think this is what it will look like. Right? So if it looks something like this, then what will happen in this particular case? We will be able to say that the value of x can be equal to 0 and the value of x can also be equal to 0, because in this case, I am going to have 3 roots because it is a cubic. So if it is a cubic, it will have 3 roots. If all of them are distinct, fine, but these 2 roots will have to be equal, which is not possible because there are 5 distinct x-intercepts, so which means there are 5 distinct roots that are present. That is why I cannot have D being equal to 0. If D is equal to 0, then I will have 2 roots that are going to be equal to 0, which is not going to be possible in this context. Let's look at the next one. This is a fairly easy question, so try this and then have a look at the solution. The graph of the function y equals f of x is symmetrical about the line x equals 2. So let's first draw x equals 2. So this is the normal y-axis and the x-axis that we have. Let's say this is 2, 0. Then I'm going to get this line, which is going to be equal to, x equals 2. Now, if it is symmetrical about this line, we can say that, okay, it might look something like this, where it will go like this and it will be reflected from the x-axis. Whatever is to the left of x equal to 2 will be the same as whatever it is to the right of x equals 2. Now, that will basically tell me that whatever will happen at 1, 0 will be the same thing that will be happening at 3, 0, because you are moving away in the same manner. Whatever happens when you put x equal to 0, the same thing will happen when you put x equals 4 as well. So this is basically how the function is going to evolve. And that is basically what we have to find out. So how exactly will we be able to represent these equalities? So in this particular case, we should be able to say that whatever is happening if you add 1 to 2 will be the same as what will happen if you subtract 1 from 2. So 1 and 3 should be the same. So let's say, for example, I try to figure out how can I make this f of 3. I'll put x equals 1. So I am going to get f of 3 equals f of 1 minus 2, that is minus 1. But f of 3 is not equal to f of minus 1. It is equal to f of 1. So this is not going to be right. What about this one, 2 plus x and 2 minus x? Let's put x equals 1 again. So f of 3 in this case is going to be f of 2 minus 1, that is equal to 1. It makes sense here. You can put one more value and see, just for the sake of being sure. You can see that, okay, let's say I want to put f of 0 and f of 4. I want to compare those. So let's put x equals 2. So I am going to get f4 equals f0, which is again consistent. You will be able to see that we are going to add 2 to x and or we are going to add x to 2 and we are going to subtract x from 2. So of course it is going to be symmetric. So this is true. And f of x equals f of minus x will be the very definition of an even function, which means that they are going to be symmetrical, or these two functions or the line that we are going to get is going to be symmetrical around the y-axis. So the correct answer here is option B. Let's look at the next question. You have to find f of 13, where when we know f10 and f15, and we also know this equality, which says f of x plus 2 equals twice f of x minus f of x plus 1. So what do we do with this particular thing? You can maybe try to write down everything and then try to figure it out. But one way of doing this is to just shuffle the terms and figure out what exactly is the sequence, because this is a very nice sequence that we have. So we will be able to say that 2f of x will be equal to f of x plus 1 plus f of x plus 2. So this is kind of like a reverse double Fibonacci sequence in a way, because what I am doing here is I am going to add the next term to the term that comes after that and divided by 2 to get the previous term. So we are going in a reverse manner. So let's say, for example, we are saying that, okay, there is going to be some value for F10, there is going to be some value for F11, some value for F12, F13, F14 and F15. So of course, as we go towards the right, the values will get derived. So let's say that the value of F10 is 20 here. Let's say the value of F11 is A. Now what can you say will be the value of F12 on the basis of this? You will be able to say that twice f of x, that is twice of 20 or 40, will be equal to F11, that is A plus F12. So what can I say about the value of F12? It's going to be 40 minus A. You can also look at this. If you add these two, you are going to get twice of 20. Similarly, I will be able to figure out F13 as well. Now I know that this is A. So the sum of these two should be equal to 2A, which means that this 40 has got no place in my solution. So I'll balance it with a minus 40. And because I need to get a 2A by adding these two, I will be able to write 3A here. Why? Because I already have a minus A, but I need 2A. How do I go from minus A to 2A? I will add 3A to it. You can also do it using equations. You can also say that, okay, 2A will be 40 minus A plus F13. This is also a way in which you can do this, but I'm just trying to skip this step. So in this particular case, we are going to get F13 equals, the A will go here and it will become 3A, 40 will go to the other side, will become minus 40. So 3A minus 40 will be this. Now you will be able to figure this out as well very quickly. I need 80 minus 2A. Now if I need 80 and I already have a minus 40, I need to have a positive 120 here. And I also need a minus 2A here, but I have a 3A here. So what will I have to do? I will have to subtract a 5A from this. Now same thing I can do here as well. I need to get 6A, but I have minus 5A. How do I come to 6A from minus 5A? I will add 11A. Also, I need to have a minus 80 here, but I have a 120 here. So how do I get a minus 80? Minus 200. So if this comes to you intuitively, your life will become much easier. You can just add these and see as well, just for the sake of posterity. So 11A minus 5A is going to be equal to 6A, and 120 minus 200 is going to be minus 80. Half of this is going to be 3A minus 40, which is basically this term. So this is one way in which you can solve this. You can also cascade and do it, but that will involve writing a lot of things. This is a much quicker way to do this. So F15 is 11A minus 200, but I know for a matter of fact that F15 is 108. So 11A minus 200 is equal to 108. 11A is going to be equal to 308, which means that A is going to be equal to 28. 11 2s are 22 and 88. So A will be equal to 28. I need to find the value of F13. So I cannot really mark 28 as my answer directly. So what will I do? I'll just substitute A equals 28 here. 28 into 3 is 84. Minus 40, my answer is going to be 44. That is option C for this particular question. Let's look at the next question. This is also a very interesting question. So try this out and then have a look at the solution that will follow. Now we know that the sum of the first x, or the sum of the functions that you get when you substitute the first x natural numbers, is going to be x square times h of x. Now h1 is 2006, that is what we know. We have to find what is the value of h 2005. Now we have to figure out, if I want to find h 2005, I will need to find out what is going to be the sum till 2006 and then or 2005 rather, and then I will have to subtract the sum till 2004. So that is something that I will be able to do. So in effect, I will have to figure out two values, h1, h2, h3 till the time you reach h 2005. So this will be something. And the other bit will be h1 plus h2 plus h of 3 and so on till the time you reach h of 2004. Now, if you subtract the second from the first, you are going to be left with h of 2005, which is what we need to solve. So this is the path to solution that you will visualize. Now you have to ensure that you are reaching here. Now how do you reach here? Everything is dependent on h of x. So let's try to explore what happens. Now we know that h1 is going to be equal to 1 square into h of 1, which makes sense because h1 will be equal to h1. But in this particular case, I know that h1 is 2006. What if I am looking at h1 plus h of 2? What am I going to get here? If I add these two, I am going to get x, that is 2 square into h of 2, or 4 times h of 2. In other words, I will be able to get 3 times h of 2 equals h1, Or if I just write it here, H2 will be 1 by 3 into H1. This is what we are going to get. Similarly, if I were to figure out the third possibility, H1 plus H2 plus H3 is going to be equal to 3 square, that is 9 times H3. Or in other words, I will be able to get 8 times H3 is equal to H1 plus H2. But what is H2? H2 is 1 by 3 times H1. So H1 plus 1 by 3 times H1 is going to be 4 by 3 times H1 here. So what am I going to get? 4 2s are 8. I will be able to see that H3 here is going to be equal to 1 by 6 into H1. Now, those of you who are keen, you will be able to find a pattern. You have seen the squares. If you know 3, 6, you can guess the next value that is going to happen. So let's see. If you look at the next part as well, H1 plus H2 plus H3 plus H4 is going to be equal to 16 H4. So this will be 15 times H of 4. But what do we know about H1 plus H2 plus H3? I know that H1 is H1 itself. H2 is 1 by 3 into H1. H3 is 1 by 6 into H1. So what I will get in this particular case, this will be nothing but I will have 6 in the denominator and I will have an H1 as the multiplier. Now what do I get here? If 6 is in the denominator, then H1 will have a 6 because it is 1 by, it's 1 itself. Then I will have 2 here because I will have to make this 2 by 6 and this will be 1 by 6 itself. So I am going to get 9 by 6 here, 6 plus 2 plus 1. Which basically means 3 3s are 9, 3 2s are 6, 3 5s are 15, and as many of you would have guessed, H4 is going to be 1 by 10 times H1. What is this 3, 6 and 10? What are these numbers? 3 is the sum of the first 2 natural numbers, 6 is the sum of the first 3 natural numbers, 10 is the sum of the first 4 natural numbers. So if you know this pattern, it will become much easier. So Hn in this particular case is going to be equal to sum of the first n natural numbers. So it's going to be n into n plus 1 by 2 multiplied by H1. So this is what we are going to get. That is what we want to find out. So one way to do this is you can just take the sums, you can figure out the sum and then do it, but that is going to be a tedious process. So what you can do here is, I know that, okay, this is basically what it looks like. So in this particular case, h of n is 2 upon n into n plus 1 times H1. So if I want to find H 2005, it is going to be 2 divided by 2005 into 2005 plus 1, that is 2006, multiplied by the value of H1, that is 2006. So I'll be able to cancel these two out. My answer is going to be equal to 2 divided by 2005. Let's look at the next question. Very interesting question. So try this out and then have a look at the solution. Part of the graph of fx equals ax cube plus bx square plus cx plus d is shown. We have to find out what is the value of b here. So I can see 3 intercepts. I can see 2 x intercepts, which are the roots, and 1 y intercept, which is 2. So let's see what we can get here. So of course, this is the this is the x axis, which means that you can plug in values from x here, and this is the y axis, which is the representation of f of x here. So what can we see here? We can see that when x equals 1, f of 1 will be equal to 0 because this is lying on the x axis. Therefore, we can say that if x equals 1, I will be able to say that a plus b plus c plus d equals 0. That is something that I will be able to figure out. The other thing that we are saying is f of minus 1 is also equal to 0. So what will we be able to say? Minus 1 cube, that is going to be minus a, plus minus 1 square, that is 1, that is plus b, plus c into minus 1 is going to be minus c, plus d as it is also going to be equal to 0. Now, on the basis of these two things, you will be able to see something that is happening. And of course, the third part should also be able to help us. Now, we are also saying that if I put x equal to 0, then I get the value of f of x equals 2. So I will be able to see that f0 equals 2. Therefore, I will be able to see that x cube will translate to a 0, x square will be 0, cx will be 0. Therefore, I will get the value of d as equal to 2. Now we have to figure out what is going to be the value of b in this particular context. So let's see what we get here. Now, if you are looking at this particular bit, a plus b plus c plus d equals 0. We can also see here that a plus c equals b plus d. That is what we are going to get. So what we can do here is, instead of a plus c, we can substitute it as b plus d as well. Now, instead of a plus c, if I put b plus d, I am going to get 2b plus 2d equals 0, or I will get the value of b as minus d. But the value of d is 2, so the value of b becomes minus 2 here. So the correct answer here is option B. Let's look at the next question. There is a function given and g of x is f of x plus 1. We have to figure out whether g of x is an even function, if it's an odd function, if it is neither even nor odd. We have to figure out what kind of a function is it. So let's see what we get here. Now the function is said to be an even function if f of x is the same as f of minus x, or in other words, the function should be symmetrical around the y-axis. So here if you just put g equals, or if you just try to figure out g of 1 and g of minus 1, you will be able to see if it's an even function or not. So I say that let's find g of 1. Now g of 1 is going to be f of 2. What is f of 2 here? F of 2 is going to be, this part will be 0, 2 minus 2, 0, 2 minus 3 is minus 1, mod of that is 1, 2 minus 4 is minus 2, mod of which is 2. So I am going to get the value of g of 1 that is equal to f of 2 that is equal to 3. What about g of minus 1? G of minus 1 in this case is going to be equal to f of minus 1 plus 1 that is 0. Now what do we get if we put x equal to 0 here? I am going to get the value of the first bit as 2. Then 3 and then 4, because 0 minus 2 is minus 2, mod of which is 2, 0 minus 3 is minus 3, mod of which is 3, 0 minus 4 is minus 4, mod of which is 4. So 2 plus 3 plus 4 is going to give me a 9 here. So I will definitely be able to say that g of 1 is not equal to g of minus 1. But the hallmark of an even function is that it has to be symmetrical around the y-axis, meaning that g of 1 has to be equal to g of minus 1. But that is not working, so it is definitely not an even function. An odd function is also not going to be possible here, because for a function to be odd, it has to be the case that g of 1 should be equal to minus g of minus 1. So it should be reflected around the origin. It should be in the opposite quadrant, but it should look similar. So that is what we are looking at. But in this case, they are not even numerically the same. So if they are numerically the same and sign-wise also they are the same, then we say it's an even function. If they are numerically the same but signs-wise they are opposite, then we say it's an odd function. So definitely it's not an odd function either. So it's neither an even function nor an odd function. Let's look at the next part. We have been given two functions here, so try this and then have a look at the solution. So there are two ranges. If x is less than minus 1, then the function will be 1 plus mod of x. If the value of x is greater than or equal to minus 1, so minus 1, 0, 1, 2 and all the numbers in between as well, then I'm going to get square bracket x, which is the greatest integer function that is less than or equal to x. Now we have been given a function f of minus 2.3. So first I will have to figure out what is f of minus 2.3. Now because minus 2.3 is a number that is less than minus 1, my answer here is going to be equal to 1 plus mod of minus 2.3, which is going to be equal to 1 plus 2.3, or I will be able to say 3.3. Now what does that mean? My answer is going to be f of 3.3. Now what is f of 3.3 according to the question? It is greater than or equal to minus 1. It's definitely greater than minus 1. So my answer is going to be square bracket 3.3. Now we are trying to figure out the greatest integer that is less than or equal to x. Now equal to 3.3 is not going to be an integer. So I need to figure out the greatest integer that is less than 3.3. What all integers are less than 3.3? 3, 2, 1 and so on and so forth. What is the greatest integer that exists that is less than 3.3? It is going to be option D, that is 3, which is the answer to this question. We also have one more question here. If f of x equals 2x square plus 3x plus 4 and g of x equals 5 minus x square, what is the value of minimum of f of x minus maximum of g of x? Now you have to understand one small thing, or if you know your derivatives then even better. But one thing you can understand is that whenever you have a quadratic in the form of ax square plus bx plus c, the maxima or the minima, depending on the context, will happen when x equals minus b by 2a. And why is this the case? This is purely the case because if you look at the kind of graphs that you are going to draw, between the two roots is where your maxima or minima is going to happen. Now you have to understand one thing. If a is greater than 0, then I am going to get a curve which will look like this, which means that there will be a minima here. And if a is less than 0, then I'm going to get a curve like this, which will mean that it is a maxima here. You can also look at the question here. We are trying to figure out minima of f of x. So of course, because the coefficient of a is positive, we are going to get the minima of this equation. And because the coefficient of x square is negative here, we are going to get a maxima for this particular equation. So what are we going to do in this case? We are just trying to figure out what exactly is going to happen. So one thing you can do is you can simply use minus b by 2a. Coefficient of x, the negative of that, divided by twice the coefficient of x square. So if I have 2x square plus 3x plus 4, I am going to be able to say that the maxima or the minima will happen when x equals minus 3 by 4. Now I just substitute x equals minus 3 by 4 in this and try to figure out what is going to be the minima of this. So minima of this particular expression is going to be 2 into minus 3 by 4 whole square, which is going to be 9 by 16, plus 3 into minus 3, that is minus 9 divided by 4, plus 4 as it is, as it's a constant term. So what will be the total of this? I will be able to say that, okay, let's just remove this and let's put an 8 here. So what I will be able to get is I will be getting an 8 in the denominator. And what do I get in the numerator? This 9 will be as it is. Minus 9 should be multiplied by 2 because I need to make this 4 and 8. So I will get an 18 here. And because there is a 4 standalone here, it will be multiplied by 8 and I will get a 32 here. So my total is going to be equal to 32 plus 9, that is 41. 41 minus 18 is 23 by 8. So the first bit is going to be equal to 23 by 8. What about the next bit? So for those of you who are into derivatives, you will also be able to figure this out using derivatives. So 2x square, the first order derivative of 2x square is going to be equal to, this 2 will come down, get multiplied by the coefficient. I am going to get 4x plus the derivative of 3x is going to be equal to 3. The first order derivative should be equal to 0. So x will be equal to minus 3 by 4, exactly the same thing that we have got here. So that is basically how derivatives are formed. Also, if you look at the second part, now you can try it using derivatives as well. Now, if I want to figure out what is going to be the value when I differentiate this with regards to x, I am going to get 5, you are going to get nothing, minus 2x square. Now, when I say minus x square, then I am going to get the value as minus 2 of x. Now, minus 2 of x will be equal to 0 in this particular case. So, x equals 0 is where you are going to get the minima or maxima rather for this particular expression. So, x equals 0 basically means that this value is going to be equal to 5. Also, you can use logic and try to figure it out because I am going to remove something from 5 and it is x square. X square can be at least equal to 0. So the minimum value that I will be able to remove from 5 is going to be 0. 5 minus 0 is 5 itself. So 23 by 8 minus 5 is going to be 23 minus 40 divided by 8, or I will get minus 17 by 8. So the correct answer to this particular question is going to be option D, that is minus 17 by 8.